Hi, everyone. This is Alan Schimmel of DevOps.com, and welcome to another DevOps.com webinar. Today's webinar, which is sponsored by our friends at Puppet, are security implications of a DevOps transformation. It's actually a subject matter that's kind of near and dear to me, and looking forward to a great webinar. Before we hand things over, though, I just wanted to quickly mention a few housekeeping chores and subjects. Number one, we've set aside time for questions from our audience. We think it's really invaluable to the whole webinar experience. But rather than waiting till the end of the webinar to pop your questions in, we'd like you to use your GoToWebinar control panel. If you scroll down, you will see a question section. If you hit the little arrow or caret to make it down pointing, it should pop open, and you can see that you could ask your question in there. I ask you to do it for two reasons. Number one, you don't have to worry about forgetting it. You can ask your question in real time as it pops into your head. It'll be queued automatically, and at the appropriate time, we could ask and hopefully get you a good answer for that webinar, or for that question. Number two is oftentimes we get a lot of questions from the audience, as you can imagine, and we don't have enough time to answer every single question on air. By putting it in our question queue, we do have a written record of it so that we can get a written answer perhaps after the webinar. We'll post it along with the slides and video of today's presentation. So please, don't wait till the end of the webinar to ask your question. Write it in as it comes into your mind, and it's there, and we'll get to it. Another interactive feature that we use in our webinars are polling. And I got to tell you, having done literally dozens of webinars, the ability to interact with the audience like that, where we can ask a question, get your feedback, understand where you are in your process, understand, you know, who the audience is in terms of you know, where you are on a journey, or what your views are on a sample thing, are all it really makes a huge difference. So please, the polling questions are usually multiple choice. They take all of about a second, 2 seconds to do, but they're only as good as your input. So please, you know, take the time to answer the polling questions, because the better data we have, the better it is for everyone. Lastly, I'd like you to look at your control panel down at the bottom to your chat section. Here at DevOps.com webinars, we don't use the chat section for questions, the question sections for questions, but we do use the chat section if you're having any audio or video issues, but you can still communicate via the chat window. We do have engineers on standby who can come in and hopefully, you know, try to address any issues you might be having. So use chat for technical issues and that type of thing. But be advised, right, when with chat, you have the ability to broadcast to the entire audience in some cases, and in other times just to the organizers or presenters who will be able to help you. So with that out of the way, let's turn back to our webinar today. And as I said, it's sponsored by our friends at Puppet, Security Implications of a DevOps Transformation. And you know, I think it's something that's looked over many times. I think many organizations are so eager and happy to get their DevOps digital transformation underway that oftentimes security implications, like all too often in security itself, are a bit of an afterthought. But if you're going to do it, we're going to do it right, and that's what I think we're going to try to show you today. So if we could go to the next slide, and let me introduce our primary presenter today. We're lucky to be joined by Greg Sargent, who's with Puppet, Manager of Professional Services. Greg recently came to IT about 20 years ago, as you can see. But more importantly, beyond being, you know, with Puppet, Greg is actually a real-life user of Puppet since, as he says here, 2012. And I will find you sometimes those make the best employees, when you can find someone who actually uses the product. Loved it so much that they come to work for the company. And Greg, welcome today to DevOps.com webinars.
Thank you very much. It's a pleasure to be here.
Thank you. Actually, Greg, you know, the issue of users becoming employees, isn't that Sanjay, your CEO, is actually a corporate user of Puppet, right?
Yes. Yeah.
And then liked it so much that he became the CEO. So it's a path there.
Yes, it goes. It pervades the organization. It's very good.
Yep.
Yes.
So, Greg, we're looking forward to a great webinar and a very interesting topic today, and we're going to turn it over to you.
All right. Thank you very much. So yes, as you heard, this is going to be a talk about the security implications of a DevOps transformation. I was asked to do a talk about, broadly speaking, DevOps and security, and I sort of chose security implications fairly intentionally. I don't, you know, I don't really subscribe to the belief that there is a thing that you can say about, DevOps will have this effect on security or that effect on security. DevOps, as we all know, is sort of a larger, sort of broader transformation, and like any such thing, there are considerations and implications of that we need to be taking into account. So I've always found it more instructive to think about, what is it that we're doing as we embark on these transformations, and how can we be thinking about the security implications in a way that allows us to act on them. So that's the approach I wanted to take here. Just really briefly, I'm going to give an overview of this talk. We'll then sort of establish a technical baseline for the DevOps conversation, and then go into some of the implications of security. So as you've heard, while I'm currently a manager of the professional services team, I've been at Puppet. I've been a systems administrator, release engineer, software developer for 20 years or so. So the bulk of my technical experience is sort of hands-on implementation, and I still come from that world. And I've been in a lot of different types of organizations, some very highly secured, some more run-and-gun startups. So I've seen this transformation happening from a lot of different angles, and have given it a lot of thought. So before we jump into the talk itself, we have a few poll questions and that I'd like you to answer, just to get a sense for everyone's sort of backgrounds and interest in the topic here. So those I think should be coming up shortly, but the first question is, do you currently work in an IT security role? And actually lost the presentation briefly. The second is, how would you describe your company? You'll see all three of these, but the second is, how would you describe your company's appetite for DevOps? And the third is, what is your opinion of the interrelation between DevOps and security?
So Greg, if it's okay, I'll help out with the polling questions here. So with the first question is, do you currently work in an IT security role? Yes or no? And you probably either work in security or you're coming at this from the DevOps or Dev or Ops side. But I think most people voted. Let's close this question off in 5, 4, 3, 2, 1. And can we see the survey results, please? So, as I would suspect, Greg, from a DevOps.com webinar, 71% are not currently in an IT security role. 29%, almost a third, a little under a third, are in an IT security role. Perfect. But Greg, if I may, I would propose to you that that's a trick question, because security should be everyone's job. But that being said,
fair enough. Yes, but there is, there are today the reality is there are organizational demarcations around some of these things, and so it's instructive to know if someone is coming at it specifically from that perspective as part of the charter of their role.
Absolutely. All right, let's pop our next poll question up if we can. Okay. How would you describe your company's appetite for DevOps? And there's a multiple choice. You're currently employing DevOps principles and practices. You're just starting to undergo your DevOps transformation. You're evaluating a potential DevOps adoption down the road. Or you really have no plans at all to do DevOps anytime in the foreseeable future. So if you guys can vote, we have a very attentive audience. We're well over 70% already. I like to try to get at least 75% of the vote in. So come on, a few more people and we're done here in 5, 4, 3, 2, 1. And let's see, what was the vote? What were the results?
Good to see
What
that
do you
zero.
think?
Yes.
Well, it's a case when you're a hammer, everything looks like a nail. People not interested in DevOps don't usually come to our DevOps.com events, Greg, but it is good to see the
Yeah.
zero.
I believe in completeness, yes. So no,
Yes.
it's good to see that, and that's about what I would suspect. So there's, I think we've got a majority, but a small majority who are, in that undergoing the transformation stage, and then on either end, people who feel that they're currently there or are just starting to dip our feet in. So
Yeah, I think that's what we see in general. And I think we have one more poll question, Greg.
yes.
All right, let's run our third poll question. And that is, what is your opinion of the interrelationship between DevOps and security? Select one of the following. They are inconsistent with one another. DevOps practices make robust security more difficult to execute. I'm going to assume the E.
Yeah, it looks like it got cut off, length limit.
Yep. And then DevOps and security are unrelated. And then DevOps enhances an organization's security posture. So again, if we could have your vote, I know there's a little bit of a harder question you're going to probably have to think about. But let's close off voting in just another 5, 4, 3, 2, 1. And our answers say, good. That's what I was hoping it would say, but I didn't think it would be this overwhelming.
Yes, nor did I. No, so that's this is good. Okay, excellent.
Excellent.
Yeah.
So
well, I'm glad I didn't spend a lot of time trying to convince people of that.
Yeah. Well, I think I always make it akin to the Meatloaf song, 2 out of 3 ain't bad, with the third usually being, you could go faster, have higher quality, but you can't have security too. But I think in DevOps you can. And I hope so. All right, let's, if we could pop up your PowerPoint.
Yes, we can do that. I thought we could. There it is.
There we go. Actually, I think you've got it reversed, Greg. We're looking at your presentation manager. Yeah. There we go.
All right. And we're back. So great. Thank you all very much for doing that. So I'm going to do, and this will probably seem a touch counterintuitive for the DevOps.com crowd, but I've found this for some time to be a good way to sort of build a foundation about DevOps. So I am going to spend a little time actually just talking about what we mean by DevOps. And I'm doing this for a reason. A lot of the time that I spend these days out in the field in my job and talking with our customers and that sort of thing centers around, hey, we want to make this DevOps transformation. We want to get into it. I hear DevOps is the thing we want to do, but I don't really understand what it is. And so and some of this is fed by the way that we discuss DevOps sort of throughout the community. And by design, right, a lot of what we say about DevOps is fairly loosely defined. We don't want to be too doctrinaire. We don't want to say this is what DevOps is, follow these steps and you are at DevOps, right? Because much of the power of this transformation lies in its sort of dynamic nature and our ability to adapt within some kind of commonly agreed upon principles to meet the needs of a wide range of organizations. But as a result, a lot of what we talk about in presentations about DevOps, we focus sort of on what DevOps isn't, right? There is that sort of 3 T's thing. It's not a tool or a team or a title. We'll talk about the value proposition. So we define the negative space. We talk about the implications, the benefits of adopting DevOps, or sort of high-level characteristics of organizations. We have fewer silos and there are some common tools, but does that mean that if I get rid of all my silos and drop in a continuous integration server, I'm doing DevOps suddenly, right? So because of that sort of more high-level conversation, it makes it a little harder to quantify things like what are going to be the impacts of my organization's security posture if I undergo this transformation. So I've actually started taking a different approach to DevOps talks and kind of simplifying the conversation back down to the initial notion of taking an application and putting it on a server, right? And let's kind of strip all of the other sort of high-level talk away, all the complexity away, and instead look at DevOps through that lens of what I'm trying to do at the end of the day. Maybe it's a distributed app across multiple data centers and multiple tiers, and maybe those servers are virtualized or cloud servers and being spun up on demand and managed as software. But fundamentally, it boils down to I have some functionality in an application that I need to get onto a server so that my customers can get to it. I will make a small disclaimer as I go through this. I present examples of all of these technologies, and obviously I work for Puppet, but I want to make very clear, none of the examples that you see in here should be considered endorsements of one product over another. One of the things that I've always loved about this space, about the DevOps community, is that from the beginning, when I started getting involved in it, I would hear over and over and over again people saying, I use Chef, or I use Puppet, or I use Terraform, or I use Jenkins, but they would say, I don't care what you use, I just want you to use something, right, to solve this problem. And I love that ethic, I love that belief, and I believe very strongly in it. But I do find that for purposes of illustration, it can be helpful to have concrete examples of things rather than talking about things like package management and continuous integration in the abstract. So I've used examples where appropriate, but please don't think of those as endorsements. So that conscience clearing out of the way, let's just build up sort of a brief technical foundation of what we're going to be talking about when I say the word DevOps, right? I've long thought that we need sort of a hello world for DevOps. Just as you're learning any new programming language, right, you always start off with hello world. We've got a new sort of way of doing technical work, and I find that people struggle with that. What's the base case? What is the simplest sort of thing I can wrap my head around to understand what it is that we're getting into? And so over my time, I have settled on kind of 5 key components that I consider to be fundamental to the majority of DevOps implementations. We'll almost always see version control, package management, automated testing, continuous integration, and some kind of infrastructure as code implementation anywhere. There's lots of stuff around this outside of these things that can contribute. Sometimes some of these things are missing from a particular hands on the keyboard technical implementation, but broadly speaking, I find this to be sort of the core of that. So to sort of understand the role of all of these things and what the implications to our security posture are of implementing them all, let's do kind of what people do, right? Let's start up a new company. We'll call it, since I wanted it to be Hello World, we'll call it helloworld.com. There is actually a helloworld.com. Its page is more interesting than the one I put together here, but that's why I don't start businesses for real. But if I'm going to do this, right, let's put a website out there, going to put Hello World on it. Everyone wants to be told hello, so they're going to come to my site, and I'm going to get all kinds of ad revenue, and I'm going to retire young. And it's really easy to get this started up, right? All I need is a server, a host to put this on. Maybe it's a VM, maybe it's an old machine in my basement. I install a web server on it, and then I write an application. And when I'm starting this up, my initial development workflow isn't really a development workflow at all. It's the simplest possible thing I could do. I'm going to log onto my server, going to write a web page, end of story, and now I've got an application. And then when I put this out in the field, I learned what everyone who has ever released any application to a user does, which is I haven't really met all the requirements of my users. People are going to want to use it in multiple ways. And in my case, it turns out that I was very, sort of Anglo-centric when I wrote it, and I've got a very lovely English language Hello World page. But that doesn't really address the needs of the majority of the world, right? So no one wants to go to hello English speaking world. Well, maybe a few, but that's not who I was going after. I need to extend the functionality of my website, but I'm not a linguist, and I really didn't get into this to be a software developer. I've got a business to run now. So I'm going to do what everyone has always done in this case. I'm going to hire some developers, right? So I happen to know the world's foremost experts in getting the words hello and world on web pages. So I'm going to bring them into my organization and set them to work, enhancing my website while I go about running the business. And right here, right off the bat, I have introduced the first real complication that organizations start trying to address as they build up these sophisticated scaled development processes that lead to what we call DevOps, and that's collaboration, right? I've got 2 people now instead of 1 working on my code, and so now I have to ask and answer all of these questions like, who owns this file, who's editing it, how do I get it changed, right? And I could, I can talk with my colleagues over lunch and figure it out. I can look over your shoulder and ask what you're doing, or I can stick a bunch of sticky notes to your monitor to get this going. But any time that I as a human being spend doing this work of collaborating with you and just figuring out how not to step on one another's toes is time that I'm not spending actually writing the code that I'm there to write. So we can improve this situation by offloading all of that effort onto a version control server, right? And so this is where we introduce version control. And what version control gives us, and I know this is going to be familiar to many, but maybe not for all, but right, what version control gives us is an authoritative source for application code, right? It allows me to track the history of my files, both store them in a central location if I want, or also have distributed copies, so I have a lot of resiliency in how those files are stored. I can take care of conflict resolution. I can roll back, broken versions of the files. So all of that work that had been sort of manual, human effort to just reconcile the work that my team is doing amongst one another has now been offloaded from my people and shifted onto a computer that is better suited to do this kind of rote task. And so now my developers have more energy to write code, and I've got a system doing this versioning information. But as we introduce these new systems, we now are immediately starting to get into some security implications, right? So one of the obvious security implications of introducing a version control server, and this is going to be a recurring one, I'm not going to repeat it for everyone, but we can assume this is true for everything, is it's a new attack vector, right? This is just, it's some new thing in my infrastructure that a person can attack. But the thing that makes a version control server a particularly interesting attack vector is that it hosts code that is going to be propagated to many machines in my infrastructure, right? So it becomes, it's a very sort of appealing target to people who want to compromise infrastructures, because if I can get access to a single system or a cluster, if I can get access to your version control system directly, then I can indirectly gain access to some or all of the other servers in your organization by compromising the code there, right? So what becomes important to consider with that version control server is, what are the access controls around it? Are the people, hopefully it's not on the open internet with, open access, but even within an organization and where we're behind a firewall, are we really making sure that the people who have access to it have the access that they need and know more? And these are trade-offs, right? They're, as companies grow, we have to start asking questions about, well, can I just sort of implicitly trust everyone? Is the team small enough that I don't have to worry about programmatic access controls and we can all agree? Or have we just gotten to the point where we're scaled too large and it's impossible for everyone to know each one else, and we have to start implementing more robust access controls on the version control server itself? Some people can only view code and submit pull requests. Others can actually commit those requests. So this all feeds into the design of our version control infrastructure from a secure perspective. But one other thing that sometimes escapes notice or consideration when implementing version control that has profound security implications is the storing of sensitive data in a version control repository. And this usually, at least in my experience, takes one of two forms. Either you'll have an application properties file that has credentials for that application embedded in the properties file, and maybe you'll have a development and testing and production version of that file. So that file has perhaps sometimes even unencrypted production passwords in it, and we're sort of relying on the fact that this file will be only accessible to root and the account that runs the web server application, and a person wouldn't be able to read it if they got onto the system. Or when we get into infrastructure as code, sometimes people will do system configurations, setting up local system accounts or users, and putting their credentials in their infrastructure as code files and then committing those to version control. So the thing that's insidious about this is that sometimes people will do that. You'll commit a file with sensitive data and say, shoot, I need to get that out of there, and remove the file from the version control repository. But because the reason of the version control repository is to track the history of those files, you can't just delete remove the file and get rid of that data. That commit with the sensitive data in the file is recorded for all time. And so if someone were to get access to that file, they could go back to the version control server, they could go back through the history of that file and figure out what the passwords were, at least at the time that file was committed. And if we didn't change them, we didn't roll them, we expose that data to risk, right? So often what people are doing more and more these days is either encrypting any of that data that ends up getting committed to a version control server, or just not putting sensitive data in code that would get committed to version control at all, and instead using some sort of an external key store to store that data and separate the two entirely. And all that gets committed to my version control repository is references back to that key store, and all of the retrieval and decryption of that sensitive data happens on the client end. So those are some security implications to consider as we start implementing version control. But now I've got a nicer workflow, right? I can commit my files to my Git repository and check those files out onto my production server. But now I've got kind of a clunky file distribution mechanism, right? So I used to have one file that said hello world. Now I've got a file for every language on Earth. And so I've got a lot more files. And it's a little clunky now for me to just check out a bunch of files onto a server and put them in place. And if I'm doing this by hand, right, I'm not taking account of things like, what are they being checked out even to the right place? Do they have the right permissions? Is there a dependency that I've introduced, some other set of files that needs to be in place before the latest version of my website will run? And again, sort of from a security standpoint, there are a lot of organizations that have an objection to having development tools on production servers, and that can include a Git client, right, to check things out. So if I have that Git client on a server and that server gets compromised, the person who compromised it can now use that Git client to go fetch code from arbitrary repositories, if they want. And so I've increased the amount of malfeasance, if you will, that can happen once that server has been compromised by the presence of that Git on there. And I can compound this by also having, say, a compiler on there, right? So now I can just grab arbitrary code and build it and have a running service on your production server that you didn't know about. So we can get around all of those issues by introducing the notion of package management. And what package management, for anyone who's used a zip file, is familiar with the notion at its basic form of a package. A package is just an atomic collection of related files that can be deployed to a target server as a unit, right? And the real power of a package is that it supports metadata about that package. So I can embed within the package itself information about what version of my application is this, where should the files be deployed, what account should own them, are there any pre or post install tasks that need to be invoked after this is installed, and also are there other dependencies, are there other packages upon which this package depends that have to be put in place first, and I can automatically resolve all that. And the beauty of this is that I can now allow, again, a computer to handle all of this work of making sure that the files get installed in the right place and with the right ownership, and that all of the dependencies are in place, all of the kind of nuts and bolts work of getting my files where they need to be and my service dependencies in place has now, again, been shifted away from my developers and given to a computer to deal with. But I've now, again, introduced security implications. And the primary security implication of a move to package management is that, by and large, the contents of those package servers are trusted. And so we sort of implicitly will trust the fact that, well, okay, I've got my signed keys, I'm pointing to package repositories that are under the control of my organization. I'm assuming that the packages that are in there are what they're supposed to be, and I'm writing all these automated processes to pull them down. So it's easy to sort of circumvent or to sidestep the step of validating that the contents of this package are in fact what they need to be. And so as a maintainer of a package repository, it becomes of paramount importance to be monitoring and ensuring the validity of those packages, that no one is getting access to that package repository and changing the contents of packages. And as a consumer of packages from a package repository, we want to be taking programmatic steps to ensure the integrity of those files. And we can, sign the packages and distribute the keys with which the package was signed, and then we can make sure that, yes, if a package was signed with the key that we expect, then I can trust the integrity of the package. I can distribute MD5 sums of the packages that are in there, so that if somehow that gets circumvented, I can compare the MD5 sum to the contents of the package and validate before I go installing things that the contents that I expect to be in the package are actually there. Because again, a package repository becomes, once again, a very kind of tasty target, if you will, for compromise, because it's the same principle. If I can get to your package repository directly, then I can indirectly get my way onto, again, perhaps all of the servers in your infrastructure if you deploy a package that I have compromised. And package installation will generally, it'll happen as root or as an administrative account. So I can take advantage of the fact that the things that I put in this package will have some opportunity to run with elevated privileges to take advantage of that. Or I can just be monitoring account credentials and that sort of thing in a web application to gather people's data. So that's but given those security implications, this is sort of the next step of our journey into sort of a DevOps world. We start packaging up our files, and our workflow has become a little bit more sophisticated now. Right, I check my code into a version control server, I package it up, and I deploy it to production. So we're all looking really good. I've actually now streamlined all of the drudgery steps and taken them away from my developers, and then now they can just write some code, resolve any conflicts, build up some packages, deploy them. We're ready to get our internationalized version of the site in place, and we immediately learn that if I'm not doing anything to actually validate the code, the contents of these packages that I'm putting into place, then all I'm really doing is increasing the rate at which I introduce bugs into my production environment, right? So I realized I've got a lot of the back-end work done, but I really need to put some steps in place to make sure that when I deploy something, it is actually what I wanted it to be and it's going to behave the way I want. And so for all times and everywhere, when people have been confronted with this problem, they have introduced a test server, right, into their mix, or a test environment or something. So we'll go ahead and do that as well. And now I can, again, I'm making my development process a little bit more complicated. I'm not just going straight into production from my packaged offerings. I'm going through a test environment where I can do some validation. But if I'm just doing all this validation by hand, I've improved the situation a little bit. I have a chance to catch things, but not to the extent that I could, right? I'm going to be doing these tests slowly. People are just not built for this sort of thing. We're not good at looking at one thing, comparing it to another thing, making sure that they're the same, and repeating that process over and over and over again. We don't want to be doing that. Our minds will wander, our attention will drift, and so we'll miss steps and we'll skip files and we'll just start going, yep, looks basically good, and we'll miss the steps. And it's just fairly late in the game, right? I can't even begin to test things this way until I've already deployed my application onto a server. So it's been checked in, I've built a package, I've installed that package somewhere, and now I can finally verify that I misspelled a word in a text file, right? So that's a little frustrating. So what we do now, of course, right, is we automate those tests, and it has long been possible, in any programming language, right? There are frameworks now that exist, or we can write our own scripts and whatnot to automatically validate the functionality and behavior of our applications. And this, again, is offloading that sort of rote, repetitive validation work that humans aren't really built to do onto computers, which were specifically built for this kind of thing, right? The computers excel at comparing thing A to thing B and making sure that they're the same and doing that same thing over and over and over again, right? So by automating these tests, I can ensure that they will run more quickly. I guarantee that they will run very consistently. And one thing that sometimes people don't think about is that now I can run these tests much earlier in the process. I can have an automated test that inspects the contents of a file before that file is rendered in a way that a human being could inspect it sensibly. So I can validate that all the words are spelled correctly much more quickly in the development process than I could previously. And so if I run that automated test when I check the file in and catch that a word was misspelled, I stop there, fix it, check it back in again, and now I haven't wasted that effort of building a package and installing it when I knew there was a word misspelled. So this is good, and we actually, for once, rather than always being negative, I can have some generally positive things to say about the security implications of automated tests, right? I can build tests to validate the security stance that I want to have. I can validate the versions of files that are being installed or of dependencies that are being installed, so I know that it's not something with a known vulnerability. I can validate ports that are being opened. I can validate the behavior of the application. I can validate file contents and all that sort of thing, and have computers checking my security posture much earlier in the development process than I could before. I can also do those package content validations in code now rather than having to pull something down, do an MD5 hash of it, compare the two by hand. I can have some code that does that. The sort of flip side to this is that I will only be validating those things for which I explicitly write tests. So for all of the power of computers to do the same sort of thing over and over and over again in a consistent way, their glaring weakness in this regard is that they will only ever do specifically the things that we have told them to do over and over and over again. The thing that that a human brings to the table here that a computer so far can't is the ability to make a leap of judgment and say, perhaps I've introduced a new, say, caching layer into my infrastructure. Maybe I need to make sure that I'm, that the security around that I'm not opening up too many ports, that I'm not granting too many things access to the caching layer, that things that are sensitive in the caching layer aren't stored unencrypted. If we haven't actually told a computer to run those tests, it's not going to notice, that caching layer wasn't here before, maybe I should do some basic security checks on it. We have to actually build that work in and be thinking in those terms if we're going to do automated security tests. So we've made our workflow a little bit more sophisticated, and it's starting to look a little bit more like what people, I think, associate with a DevOps workflow or an agile software development workflow, right? I now have a bunch of automated tests, so my developers can write some code, run some automated tests, check it in, run some tests, deploy or build a package, run some tests, deploy to test, run some tests, deploy to prod, run some tests, right? So we've got a lot more robust development and delivery process in place. Things are looking good. Now, really, we can just have our developers, A, write code, and then B, tell computers to do all of the other steps in the path of taking that developed code and deploying it to a server, right? So we just check in the code, and I tell the computer, hey, manage the code in the version control repository and build a package in the package management system and run some tests as they go in and deploy those packages to production. And it turns out, as will shock roughly nobody on the call, I think, that there is now also technology that excels at specifically that task of telling a computer what to do and when to do it, right? And this is continuous integration, and where we come into the world of continuous integration. So this is probably currently it's a concept that I've seen more people stumble on than most others, with the possible exception of configuration management. What is a configuration or a continuous integration server? What does it do? And while there is a lot of utility and a lot of power to a continuous integration server, because when you get down to it, you can write arbitrary code and have them invoke it, at their core, right, continuous integration servers are job running engines. And so I can tell a continuous integration server to monitor something, detect some condition, and then in response to detecting that condition, kick off a series of jobs and validate that whether or not those jobs succeeded or failed. And if one fails, alert the people responsible so that we can remediate it. And so the sort of prototypical way that this is used is to point your continuous integration server at a version control repository, and anytime you detect a change to that version control repository, the CI server then checks out the code, runs some tests on the code locally, can then do the work of building a package from code that passes all the local tests, deploy that package to a test server, invoke some automated tests on the test server, deploy the package to a production server if you're ready to have it take over the production deployment as well, and then run validation tests on the production server. And this is what we call a continuous integration pipeline or a continuous delivery pipeline, where roughly the distinction between the two, in my mind, is whether or not you go all the way to production, right? So this is, when people talk about this notion of a pipeline, that's what they're talking about. And we've again introduced some new kind of security questions into the organization, because once again, I now have this continuous integration server that has access to my code, has the power to build packages from code. It has the ability to deploy code to test and production servers in my infrastructure. So once again, if I as an attacker am able to gain, I don't have to try to gain access to your entire infrastructure. I can gain access to your continuous integration server, and I have direct access to that, which then confers indirect access to everything else in your organization, right? And generally, the sorts of things, especially when we get to the delivery side of continuous integration, continuous delivery, the sorts of things that we're doing in these jobs and on these servers require elevated access. So I can, I can deploy a package, I can run a job that bounces a firewall or restarts a service, right? And worse yet, if I am able to gain access to that continuous integration server in a way that allows me to create new jobs, I can generally create a job that allows me to run an arbitrary script, right? And so depending on the access that those CI server agents have, I can now build a job that runs a script of my choosing or a bit of shell code of my choosing on some or all of the servers in a company's organization. And so once again, while these tools are very, very powerful, with that power comes some pretty heavy security implications, and we want to make sure that we're thinking about, well, who actually has access to this thing, and who, are we giving people fine-grained access to jobs that can run? Are there jobs that should only be getting accessed by a service account or through an API or something? And even if I were able to physically log on to the server, I wouldn't be able to see those jobs because no interactive access is given to them, right? Is there a very small group of people that needs to be able to create jobs and maybe a larger group of people that needs to be able to invoke jobs? And are we even partitioning which jobs can be invoked and which projects can be managed by which people? All of these things are things to consider when deploying a CI server. Generally speaking, when we do this at the beginning, those considerations come later, but it's important to think about these things because we can end up in a situation where we've built hundreds or thousands of jobs on a CI server and haven't really been thinking about the access controls to them, and now I have to go back through this huge, tedious task of securing those before we get audited or go try to do some sort of PCI thing or something like that, and that can be that can just be a huge drain on resources and morale. So being aware of the fact that this again, while is very powerful, is also a target, and constructing the CI server and its access in a sensible, secure way is an important implication. But at this point, we now have everything in place for what we've traditionally known, I think, as sort of the agile software development workflow as it's evolved over the last couple of decades, right? So now all that my software developers are doing is writing some code, and they check it into the version control server, and then they go to the bar, right? And from that point on, the continuous integration server is taking care of everything else. It validates the code that's been checked in. It builds packages when those tests succeed. It notifies the right people when those tests fail. It deploys into our test and production environments, and it does all of the notification that needs to happen if tests fail in those environments. And so this process of delivering the code that has been developed has been entirely automated, and we're sort of living the dream here right up until the point where a server fails, right? And so the sort of unstated assumption of all of this technological innovation is that it all works great as long as the servers that host all of these applications are also running great. And this is where we've brought in systems administrators. And before I reveal this next slide, I will reiterate that I was a systems administrator for a long time, so I may have a warped sense of the importance of the systems administration discipline, but this is sort of been our bread and butter as sysadmins. Server is down, server is misconfigured, I'm getting alerts, things are bad, or I need to build a new server, we need to scale out. In swoops the systems administrator to save the day. But we never really came alone. We always were carrying a gigantic run book that we had to go through sort of manually and say, let me just pull out the instructions for building up this server, and we'll get you off the ground in another 6 hours or 2 days. And I've actually been responsible for the creation and maintenance of a 400+ page not handwritten, typed manual that had to be distributed to a bunch of different labs to put down all of the instructions to build those up. I've been in that position more than once in my career. So this is a real thing that systems administrators have had to do. And so for a long time, while all of this great agile software development process was being built up, in a way, the entire sort of discipline of systems administration was acting as an anchor on this. I say this again as a systems administrator. Like I love the discipline, but we were a large sort of anchor on this systems administration, on this agile development workflow, and we've sort of made smaller and smaller anchors over the course of time. We started off with manual runbooks, and then we would automate some bits of those runbooks by writing shell scripts, and we would put things into golden images or make VM templates, and so we could reduce the number of times that we had to repetitively build everything up from scratch. But we were still building those initial images by hand and doing a lot of manual labor anytime those things had to change. So what really kind of let us take the next leap in systems administration and the management of the configuration of a machine was the introduction of the notion of infrastructure as code. And what infrastructure as code allowed me to do, again, this is there's a lot of confusion about sometimes what these infrastructure as code implementations can do, because again, sort of at their root, good word, they're going to run as root or as an administrator, and I can write arbitrary scripts. So in some ways you can think, well, they can just do anything that I want them to do, and that's true. But the problem that they were really introduced to solve was, hey, I have this big set of instructions to configure and maintain my servers. Those instructions can only be read and interpreted and acted upon by a human being sitting at a keyboard. I really want to take those instructions and rewrite them in a way that a piece of software running on a computer can read and interpret and run, and that way they'll run a lot more quickly and they'll be done a lot more consistently than any human being could do it. And so that's really, I mean, it is what it says it is, right? It's infrastructure configuration descriptions written down as code, which allows me to then, again, offload a lot of this work about, okay, now which do I install the server first, and then I reconfigure the config file, and then I restart the service, and how does that all tie together, and does that service have to be in place before this one? I can write all that as software, and then some application can take care of the nitty-gritty of implementing those instructions for me. As you can imagine, though, there are profound security implications, once again, to shifting from a model where a human being is sitting down and typing away on a keyboard to code is being checked in, and we're sort of indirectly invoking these instructions on a server. By and large, because the things that an infrastructure as code implementation or a configuration management solution has to do will run as root or as an administrator on Windows or as an account with elevated privilege, any kind of compromise to those servers can be very, very serious, because I can now run code as the most powerful accounts on those systems. And a lot of times the code in these solutions is by and large trusted. I am taking it on faith that when I build up the configuration description from whatever code my infrastructure is defined in, that code is the code that was supposed to be there, and the configuration that I'm receiving from the server is the configuration that I wanted, and I'm just going to go ahead and apply it to my server as root. And because those configuration management tools have such wide-ranging abilities, right? They can install packages, they can enable and disable firewalls, they can run arbitrary scripts, they can change passwords. There's a lot of potential to sneak something in that I didn't know. And as we move to this, both the beauty and sometimes the cause for concern with automation is these things are built to run unattended. So I'm not a human being sitting there watching myself do these things or watch, they're just happening. And so a lot of things can happen all at once, and it's harder for me as a person to process and validate the changes that have happened. So what really becomes of paramount importance for security considerations with respect to infrastructure as code isn't actually so much access to the agents or the servers of that infrastructure as code implementation. If I can get onto your infrastructure as code server, but I don't have access to the actual code, I can invoke runs, I can make servers run some tasks. I may be able to change the sorts of configuration that get applied to a server, and that can be very dangerous. I can turn a test server into a production server by just gaining access to an agent sometimes, or the server part of an infrastructure as code implementation, and that sort of indirectly allows me to see maybe production passwords where I used to only have access to test passwords. But the real concern is access to that code base. If I can get access to the infrastructure code, then even if I can only get onto other managed nodes and invoke agent runs, or if I can only get onto a centralized server and invoke runs, I can still make sure that code that I have written gets distributed to those servers that I'm running that code on, and then I can do arbitrary things on those servers. So the primary, to me, security consideration when implementing an infrastructure as code solution isn't actually as much the infrastructure as code solution itself, but it's access to that code that defines what the configuration is. And so it actually comes back to the Git server considerations. Who can get onto my version control repository? Who has pull access? Who has push access? Are we building in validation? How many eyes, whether apologize, whether pardon me, okay, whether real human being eyes or computer eyes, how many eyes are actually getting onto that code as it gets checked in. So, but this said, we've now brought our systems administrators into this software development pipeline. And now this is where I think we got all of the stuff that I was talking about before was basically agile software development. We're now into a world where we don't have an agile software development process with an anchor. We have agile software development with operations integrated into the same workflow using the same pipeline. And so now we have our devs and our ops working together. And this, to me, is sort of this base case of what DevOps is. And this is what I've been able to sort of build some kind of concrete thoughts around is this core pipeline. So really, when we're talking about DevOps, to me, and I'm trying to think about it in a practical way and think about things like security implications, the two primary things that I'm thinking about are I am employing automation in a directed way. I'm not just automating things willy-nilly, but I am directing that automation to the end of building a shared workflow for my developers and for my operations people, right? And so all of the things that contribute to that, version control for my code, storing application code and configuration code in the same repositories or in the same way, applying the same sorts of tests to them, packaging them up and distributing them to systems. Everything that sort of first builds, contributes to, and then reinforces that delivery pipeline is what I'm talking about with infrastructure as code. So there were a number of other security questions that came up, and I know we're running a little bit short on time, so I'm going to accelerate through some of this. We talked about sort of the nitty-gritty of the security implications of a lot of the tools in a DevOps transformation, but there is actually a larger perception in the community that I run into a lot that DevOps is incompatible with security. It is not shared by this crowd, but I work a lot with people who are thinking about adopting DevOps and sometimes larger organizations that are starting to get on this journey, and they hear things like faster development times and automated testing and bringing dev and ops closer together, and they are used to a model where security is kind of there slowing things down maybe, or just making sure that things are going on in a measured way, and get a little bit antsy about this transformation. And sometimes we in the community can feed this perception. Sometimes we talk about the trust side of trust but verify over the verification side of it. And we emphasize the fact that our devs and our operations people are working together, and we're checking things into code, and we're deploying configuration out there, but the process kind of ensures that the stuff is of a high quality, and so we don't need to have as much human intervention in the process to validate it. Sometimes we can be a little bit too purist about things. Or I've run into a lot of cases of people saying anything that kind of gets in the way of the wheels of progress, right? That interferes with this efficiency and with this speed is by definition not DevOps, and that can sometimes freeze out the security organizations who are trying not to just slow things down for its own sake, but just to understand the changes that are going on. And sometimes we make security an afterthought in all of this, and we're gaining a lot of very good benefits from increasing the speed and efficiency of our development process and delivery process. But if we're not, but sometimes we can just think about security after the fact, and hey, we made all these changes, this new thing got out there, let's run some scans and make sure we haven't broken anything from a security standpoint. And in some ways, security becomes the new ops if we aren't careful. And instead of, we're throwing things over the wall to operations people, now the devs and the ops are getting together and throwing things over the wall to security. But these security organizations do have real concerns, and how we address them and how we speak with them about them, I think, can really strengthen our position as a DevOps community, right? And there are obvious things that a security organization or a security team or someone who's thinking about security cares about, right? My finances and my intellectual property are the obvious ones. I don't want to risk exposure of my company's money or the things that allow us to make more money in the future. But beyond that direct harm, the thing that's, I think, even more harmful these days to companies is the exposure of customer data, and the loss of goodwill and the loss of trust and faith that happens when a major customer data breach happens can be even more damaging than the direct sort of financial harm that happens in some cases, right? And we all see that these compromises are just happening more and more often, and they're costly. But security organizations generally want, I've seen a few large sort of topics that they're interested in. They want rigor, they want visibility, and they want responsiveness. We basically want to make sure that we're not introducing any vulnerabilities into our production environments as well as we can. And we want to be able to take a look at what's happening so that we can understand what the changes are that are coming down and what the security implications are of those changes. And if we detect that something has gotten into production that is vulnerable, I want to be able to remediate it really quickly. And so interestingly, sometimes when I'm trying to have these conversations at the earlier stages, a lot of the things that seem to be strengths to us in the DevOps community can feel like weaknesses to the security organizations, right? The fact that our dev and ops teams are now working together and getting things done more quickly, while is a huge benefit to the development operation, can sometimes feel like the devs and ops, developers and operations people are closing ranks and leaving out the security folks. And it's, even if there was a horrible, clunky handoff that was going on between the devs and ops, and that slowed down our delivery lifecycle, and everyone acknowledged that that was something that needed to go, for the security folks, it was at least an opportunity to get in there and inject themselves and see what was going on and understand, the changes that were being made. So that's, that's a thing that has sometimes happened, and we start sort of throwing things over the wall to security organization. The automation upon which all of this hinges, right, does mean that we have fewer eyes and fewer minds on the code, so fewer opportunities to make judgments about what's happening. So if we're not specifically testing for something, then there's the potential that it doesn't get noticed at all, right? And so we have to be rigorous with our testing, and this again, if we are sort of excluding the security folks from that earlier phase of the operation, then the impression can be that there's a lot more risk now associated with what's going on, because no human being is sitting down and thinking sort of more broadly about the implications of a change that's being made. While the speed has obvious benefits to a security organization, one sort of negative side effect that it can have if the security organization hasn't sort of been integrated into this DevOps workflow and mindset is that it can be hard to keep up with all of that change, right? We're introducing more changes into production more frequently, which gives a security organization less time to measure the impacts of those changes. And so what we have to make sure that we're doing sort of hand in hand with this, obviously, I think, is reduce the amount of time that is required to measure the impact of a change as it's being made in these organizations. If we rapidly accelerate the development and delivery process and don't change the way that we are measuring the security impact of those changes, we put our security teams under a great amount of stress, and then we have to make sure that we're not doing that to them. But none of these are fundamental flaws. It's simply a case, if we start introducing this kind of behavior, the case is just that we have been insufficiently inclusive, right? And the obvious, I think, way to remediate this is to include security early in the process. We want to be designing for security. We want to be building tests in our testing pipeline that test our security posture and make sure that we're operating in a secure way. And we can even incorporate security into the ticketing process, into the early stages of design, so that we are catching security implications earlier on. I did just note we have about 2 minutes, I think, in the presentation. I didn't account for some of the early time, so I have a couple of slides to elaborate on these concepts, but I'm going to stop just to give a couple of minutes for people to ask questions. This is sort of the broad overview. So thank you all very much, and let me know if you have any questions.
Thank you. We do have some questions, and I think what we need to do is, if you do have these slides, we should include them with the slide download that will be available to everyone, as well as for our video recording that'll be up on YouTube. So Greg, what we maybe do is play the slides as we're doing questions in the background. We don't have a lot of time. This is really an important question, though, and it's from a fellow named Gopal Dash. And he asks, does this mean DevOps now amplifies security risk? And I was afraid we were going to give him that impression, because that's not, I think, what we want to tell them. Why don't you answer it first, and I have a thought or two on it as well.
No, it absolutely does not. And the distinction I want to make is we can give that impression in the way that we talk about things, and we can give that impression by being careless or thoughtless about how we implement these things. But the reality is each of these steps, each of these tools, each of these processes gives us the ability to actually reduce security risk and amplify our ability to validate and remediate security issues, right? So I can now write automated tests to allow a computer to validate my security stance. I can now build much more effective delivery mechanisms to get fixes into production much more quickly. I can be working together with my security team and my development team, my operations team, to build that security posture into my applications using all of these tools. The important thing is, just as with any IT transformation, any implementation, to be thinking about security and to be implementing it in such a way that it brings that security posture, to the table from the forefront.
Greg, I'll just quickly add to that. You know what? DevOps can amplify many things, and especially will amplify things that we don't account for or we don't, focus on. But at the same way it could potentially amplify security risk, it can also greatly amplify reduced security risk. The bottom line is the security you get is the security you deserve, just as someone once said about DevOps. If you make it a priority and you shift it left, as spoke about here, you can not only go faster with better quality, but you truly can have better security. It's up to you to do it. Anyway, we're over the hour, Greg. I'm not going to have time for more questions. We will try to get them in writing to you. But thank you for a great presentation today.
Thank you all for attending. Thanks for the opportunity.
Thank you. This is Alan Schimmel for DevOps.com. Thanks to Puppet for allowing Greg to appear with us today and talk about, which is a very hot topic, security in DevOps, SecOps, rugged DevOps. It's called a lot of things. We'll see you soon on another DevOps.com webinar. Thanks, everyone. Have a great day.